Now till now we have seen that mutexes are used for mutual exclusion. Now I'll show you some procedure or some process in which mutexes will even ensure the order in which you want it to execute, which means mutexes are not just used for mutual exclusion. You can even enforce some order in which you want to execute the process. Even though you let the scheduler schedule any process, you can stop and you can make the process execute in some particular order. So just watch this one. Let us say there are two mutexes A and B, and A is initialized to 1 and B is initialized to 0, and there are two processes P0 and P1, and their code is like this. So P0 will perform a down on A and then print 1, and after that it is performing a up on B, not on A. Okay, and the other one, it will perform a down on B and then print 0, and then it will perform a up on A. Now if I let these two processes run in concurrently, which means these two processes are going to be scheduled one after the other any number of times, then what is the order, or what will get printed, or how many sequences are possible? Just watch it. See, now if P0 gets scheduled, then it will perform a down on A, which means it will make A as 0 and it will enter the critical section. I mean, this is kind of critical section. Or don't call it critical section because it is not the common code. Let's write some code. Okay, then 1 will get printed, and after that it will perform a up on B. Initially B is 0, and performing a up on B with no process waiting on it will cause B equal to 1. So now B equal to 1, and now again, even if it tries to enter, since it has already made A as 0 earlier by performing the down, it will get blocked. So it will print only 1, and here it will get blocked. And what about the other one? It will try to enter it, and it will try to perform a down on B. See, here already up on B is performed, therefore B value is now 1. So down on B will be successful, and so this line will get executed, which means 0 will be printed. And now it is going to perform up on A. So when you perform up on A, then what happens? The process which got blocked there will get unblocked, and therefore it will print 1 here, and again it will perform up on B, and therefore it can perform down on B. So it will go in only this order. Either you schedule P0 first or P1 first. Only order possible will be 1 0 1 0 1 0, so on, right? This will continuously be printed. Even in case, let us assume that this is the initial scenario, which means initialization, and instead of P0 getting scheduled, even if P1 gets scheduled, let's see what happens. If P1 gets scheduled, it will try to perform down on B, and since B is 0, it will get blocked there. So P1 get blocked, P1 will get blocked here, right? And then it will, this one will get scheduled at some point of time, and then it will enter the again critical section because it is allowed. A is 1, therefore it is allowed. So it will again print 1 and then perform a V on B. This V up is going to cause wake up for the process which got blocked here. Now it will get unblocked, and it will print 0, right? And again it will give the chance to P0 by performing up on A, and even if it performs one more down on B, it is going to get blocked, right? Therefore anyway the the processor schedules it. I mean, the scheduler schedules P0 and P1. Your placement of the mutexes will always guarantee that these two statements will strictly follow strict alteration. Got it? So this is one of the advantages. You are not just using it for mutual exclusion. You are even putting the or you are even trying to control the way in which the statements get executed. This is one more advantage of mutexes. Okay.